Hello, my name is Randall K. Harp. I am the creator-in-chief at Chapel Hill Media and a music author over at AudioJungle.net. I am pleased to present this tutorial for Tuts Plus on cleaning up audio with Adobe Audition CS 5.5. You've probably seen one of those crime shows where they pull up a grainy, out-of-focus image on a computer screen that was taken from some surveillance camera a mile away. And through a series of magic rectangles, they're able to zoom in on and clearly read a sales receipt in some guy's pocket. Well, of course, that's fantasy, and the same holds true for audio. If the quality of the original recording is poor, we can't perform a miracle and make it awesome. What we can do is take out most of the stuff that we don't want and enhance what is left to improve it. And that's what we're going to do in this tutorial. If you're using Adobe Premiere Pro as part of a creative suite, you can send an audio clip from the video project that you're working on out to Audition for editing and return the edited track right back into the video project timeline. For this tutorial, however, we'll just import our audio clip from a file on disk. To do so, we'll choose File, Import, File, although I prefer to use the keyboard shortcut of Control-I on Windows or Command-I on Mac. And now the file is loaded into the Audition workspace. Let's listen to what we'll be working with. To play the clip, I can click the play button here, or press the spacebar to toggle between play and pause. I'll press the spacebar to listen. A potential problem with shooting video outside of the studio is that the audio is susceptible to varying levels as well as extraneous noises that may be picked up in the field. Fortunately, those things can be fairly well cleaned up excuse me, in post-production. There are several issues with this clip. The most noticeable is that engine sound that runs throughout the clip. Perhaps it was a gasoline-powered generator that was on location. We definitely want to get rid of that. There are at least two ways of performing noise reduction in Adobe Audition. The first way is destructive. That is, it makes changes directly to the audio clip. The second is an effect that takes the audio clip as its input, and the output is an affected signal. Let's take a look at the first destructive method. The destructive noise reduction works by capturing a noise print. Much like a fingerprint identifies a person, we want to provide Audition with a noise print that will help it to identify the noise that's throughout the audio clip. For a noise print, it's best if you can select a section of the audio clip that contains only the noise. Often you can find such a section at the beginning or end of the clip, or perhaps in pauses between dialogue. The better that your noise print is, the better job Audition will do at identifying that noise throughout the audio clip. In our case, there's this section here at the end of the clip that seems to include just that engine noise. We can drag the playhead through the clip to scrub through the audio to find the section that we're interested in. Since we have a section in this clip that contains only the noise, I'm going to use the time selection tool, which looks like the text tool in a word processing app. And I'll use it to select the time in this clip that contains the noise. There are other selection tools, and they're designed to be used with the Spectral display. To show the Spectral display, choose View, Show Spectral Display. The Spectral display shows the volume and frequencies of an audio clip in terms of color and height. Colors closer to white are louder, while colors closer to black are quieter. The vertical arrangement shows the frequencies where those volumes occur. The spectral display is useful for selecting sounds within a specific frequency range, such as a bird chirping or a bell ringing. And Audition provides these other selection tools to select specific areas within the Spectral display to edit or to use as a noise print. Using these selection tools with the Spectral display deserves a tutorial all on its own, but I wanted to let you know that they are there and can be used to select portions of an audio clip. I'll be selecting just a portion of time in the clip, so I'm going to turn off the Spectral display and simply use the time selection tool to select this last portion of time in our audio clip. With this portion of the clip selected, I will tell Audition to use it as my noise print by selecting Effect, Noise Reduction, Restoration, Capture Noise Print. Having captured my noise print, I want Audition to reduce the noise in my entire audio clip. To do that, I'll select Effects, Noise Reduction, Restoration, Noise Reduction, Process. The noise reduction window contains several controls, and each of them deserves its own tutorial, but I'll touch on each of them briefly so that you'll have at least some idea of what they do. If we had not already captured a noise print, we could click outside of this window, select some portion of our audio clip, and then choose this button to capture a noise print. The status to the right here tells us that we currently have a noise print. We can also save our current noise print, as well as load one from a file, and these can be handy if you know that you'll be removing the same noise from other audio clips. The graph displays a visual representation of the noise print across frequencies, with the blue line controlling the amount of noise reduction. You can adjust the amount of noise reduction at different frequency ranges by adding nodes to the blue line and dragging them where you want. For this tutorial, we'll keep things simple and go with the default by clicking the reset button here. The scale can be either linear or logarithmic, the latter dealing with how we perceive volumes at different frequencies, but that opens the whole discussion of psychoacoustics. We'll keep it simple with the linear display. If there are multiple channels in our audio clip, such as a stereo signal, the channel drop-down controls which channel is displayed in the graph. Since we've already captured our noise print, and we want the noise reduction to be performed on the entire file, I'll click this handy-dandy Select Entire File button to select the entire clip. You can see in the background that the entire clip has been selected. Of course, if you wanted to perform noise reduction on just a portion of the clip, you would manually select that portion and not press this button. The noise reduction slider controls the percentage that we want to reduce the noise by. The default of 100% makes sense in this case, but if I wanted to keep a bit of the noise for the sake of ambiance, I could reduce this value. In addition to adjusting what percentage of the noise, you can adjust the volume by which the percentage to be removed will be reduced by using this slider. I'll stick with the default value. The handy Output Noise Only toggle box lets you preview just the noise that is being removed when the box is checked, or the processed signal when the box is not checked. Allow me to demonstrate. Let's click on the Output Noise Only option and then preview the audio, either by clicking the play button down here or simply pressing the spacebar to toggle between play and pause.
A potential problem with shooting video outside of the studio is that the audio is susceptible to varying levels as well as extraneous
You can hear
noise.
that engine noise that's going to be removed, plus just a bit of the stuff that we want to keep, which really can't be avoided unless we want to not remove all of the noise. It's a bit of a trade-off. Now let's click off the option and listen to how the clip will sound with the noise removed. A potential problem with shooting video outside of the studio is that the audio is susceptible to varying levels. The engine noise is definitely gone, but the remaining voice sounds a bit thin and echoey, as if a reverb effect has been added. We'll deal with that in a bit. First, the rest of the controls on this window. If these advanced controls aren't showing, then click the little arrow here to twirl down this section. The spectral decay rate determines what percentage of frequencies will be processed when the audio falls below the noise floor. The online help will tell you that a value between 40% and 75% works best, but that's not always true. From my experience, in cases just like this, when the processed signal sounds thin and echoed, setting the value somewhere between 10% and 20% works better. Let's try 15% and hear how it sounds.
A potential problem with shooting video outside of the studio is that the audio
Not ready for distribution, but it does eliminate most of that phase-shifted, echoey sound. You can play with the value and listen to how it affects the audio. Smoothing takes into account the variance of the noise signal in each frequency band and can be adjusted depending upon the type of noise that's being removed. Typically, a value higher than 2 can reduce some of the resulting artifacts, but will likely increase the amount of background noise. In our case, let's set it to 1. Precision controls how fine the detail that the noise reduction process looks at. Essentially, the higher value the better, but the more computer horsepower is required. If you set the value too low, you could introduce some unwanted volume spikes or clicks. I would never go lower than 5. Transition width manages the transition between the noise reduction and the audio that you're keeping. A value of 0 is essentially a hard noise gate and can sound a bit unnatural, depending upon the audio that you're dealing with. Higher values will give more of a transition from the noise to the remaining audio. In this case, I will set it at 1. The last 2 values control the capture of a noise print and are set before capturing a noise print. FFT, or Fast Fourier Transform, size determines how many individual frequency bands are analyzed by the noise reduction process. Higher values might reduce more noise, but introduce more time-based artifacts like phase shifting and reverb-like ones that we initially heard in our affected audio. Generally, the default of 4096 is a great starting place, and you can adjust it as necessary. Noise print snapshots sets the number of individual snapshots to include in the captured noise print. The more snapshots that you have, the more noise that you can remove, but you also run the risk of removing more of the desired signal, especially if the noise removal level above is high. More snapshots also require more computing power. The default of 4000 is a great starting place that you can adjust as necessary. If you change either of these values, the FFT size or the noise print snapshots, you will have to recapture your noise print. Okay, let's preview our audio one more time.
A potential problem with shooting video outside of the studio is that the audio is susceptible to varying levels.
We could spend some more time fine-tuning these controls, but we need to keep this tutorial to a reasonable length. We've done a pretty good job of removing the noise, and I think that you now have some idea of what each of these controls does, so let's move on. Next up is actually processing our clip. We apply the processing to the audio clip by pressing the Apply button. I'm going to save what we have so far in a new file by choosing File, Save As. We'll give this a file name of Step 1 and save that. Before we continue with the other aspects of cleaning up this audio, I want to introduce you to the other non-destructive method of noise reduction, the adaptive noise reduction effect. Let's close the current file by choosing File, Close. Now let's import our original raw audio by pressing Ctrl-I or Command-I on a Mac, and then choose the raw file from disk. Now let's add the adaptive noise reduction effect to our effects rack by clicking this arrow next to an empty slot in the effects rack, and then we'll choose Noise Reduction Restoration, Adaptive Noise Reduction. Rather than working from a noise print, Adaptive Noise Reduction processes the audio in real time, attempting to distinguish noise from actual content. It usually works best with a constant noise such as a tape hiss or AC hum. Let's briefly go over each of the controls. As you can see, there are a few presets provided. Our audio is fairly noisy, so I'll choose the Heavy Noise Reduction preset. The buttons here on the right allow you to create new presets, delete presets, and mark the current settings as a favorite. The Reduce Noise By slider is the same as in the first window. It sets how much in volume to reduce the noise by. The Noisiness slider sets the relative amount of noise in the audio clip by percentage. The Signal Threshold slider adjusts the volume threshold of the signal that you want to keep, similar to adjusting that blue line in the first window. The Spectral Decay rate is similar to the Spectral Decay rate in the first window, except that instead of a percentage, the adjustment is in milliseconds per 60 dB. That is, how quickly the noise processing drops by 60 dB. This can be fine-tuned to get the most acceptable trade-off between noise reduction and resulting artifacts, such as warble or reverb. The Broadband Preservation slider adjusts the frequency range to preserve audio. That is, what frequency range above and below the detected noise the effect is going to leave alone. The lower the value, the less audio that will remain untouched, which increases the likelihood of removing noise, but also increases the likelihood of altering the desired content. As with virtually all of the noise reduction adjustments, this one is a trade-off that you can dial in for the most acceptable result. The FFT size here is similar to the first window, only instead of adjusting how the noise print is processed, this adjusts how many frequency bands are analyzed in the clip as a whole. Higher values are better for continuous noises like AC hum, while smaller values may work for more transient noises like pops or clicks, although there are other effects available for dealing with those specific types of issues. The high quality mode toggle box is similar to the precision value in the first window, but your only choices here are on and off. On will yield better results, but requires more computing power. Let's listen to what effect the current settings have.
A potential problem with shooting video outside of the studio is that the audio is susceptible.
I think that the engine noise in this audio clip is a bit too complex for this adaptive noise reduction effect. We could spend some more time trying to dial in a better result, but I'm going to proceed with the result that we achieved using the noise print method. Let's remove this effect from the effects rack, close this file, and then open the result from step 1 that we saved earlier. Before enhancing what we have left, there are still some things we want to remove, specifically this throat clearing and excuse me that we have here.
Excuse me.
If this audio were synchronized to video, we would want to get rid of this part but not change the length of the clip. We can do that by selecting the portion of the clip that we want to clean and then replace it with silence by bringing up the context menu and choosing silence. I'll undo that by pressing Ctrl-Z or Command-Z on a Mac. And now I'm going to treat it as if it was a radio interview and remove that section altogether. With that section selected, I can choose Delete from the context menu or simply press the Delete key on the keyboard. Now we have the uninterrupted thought.
This can be fairly well cleaned up in post-production.
The remaining audio contains decent lows and highs, but the noise reduction processing has taken out a bit of the mid-range frequency, so let's boost those. In this first slot of the effects rack, let's insert some EQ by choosing Filter and EQ, Graphic Equalizer 30 bands. I want to boost the mid-range frequencies just a bit, so I'll choose this preset, Gentle Mid Boost. Let's have a listen.
A potential problem with shooting video outside of the studio.
Definitely improved. Let's close this window. The next issue to address is the uneven volume level across the audio clip. There are a number of ways to address this. Volume levels deal with amplitude and compression, so we're going to add another effect in our chain under amplitude and compression. There is this speech volume leveler effect, but I prefer the tube modeled compressor. In this handy effect, powered by Isotope, I'll select the voice leveler preset. Now let's listen.
Is that the audio is susceptible to varying levels as well as extraneous
Definitely
noise.
improved. As a final touch, let's boost the overall volume of the clip. In the next slot of the effects rack, we'll add a hard limiter. Under amplitude and compression, hard limiter. I'll choose the limit to -3 dB preset. Let's listen now.
That may be picked up in the field. Fortunately, those things can be fairly well cleaned up in post-production.
Better overall. We could certainly take more time to fine-tune the noise reduction and each of the effects, but hopefully you now have a good idea of how you would go about cleaning up some noisy audio. The effects in our rack are just processing a signal. They haven't modified the audio clip itself. Before we save our file, then, we'll modify it by pressing the Apply button here at the bottom of the effects rack. You can now see how the wave shape changed as a result of applying the effects in the rack. Let's save our modified audio clip into a new file. And there we have it. In review, while we can't perform miracles on poorly recorded audio, we can improve it by removing most of what we don't want and enhancing what is left. I hope that I've shown you enough to experiment on your own, and you get familiar with the various adjustments that are available in Adobe Audition. This is Randall K. Harp for Tuts Plus, wishing you better audio and, most of all, enjoyment of the creative process.